Hello everyone, welcome back to the channel. Coming back to the topic, that is operating system process synchronization. So in last lecture we have discussed introduction of process, introduction to process synchronization, its advantages, disadvantages are and four important sections related to the working of process synchronization. Now in this video we will cover the requirements of synchronization, its important terms we are going to cover with some real life examples that are very important and will definitely help you score good marks in your upcoming college or university level examination. So before moving to the requirements, you should know the four elements of process synchronization, that is entry section, critical section, exit section and remainder section. So before moving to the requirement, you must know the critical section. What is the meaning of critical section? Okay, if you know the critical section, only then you will understand the requirements wala topic, right? So critical section is a code segment. It is a code segment where the shared variables can be accessed, where the shared variables can be accessed, right? So atomic action is required in critical section. That means only one process can execute in its critical section at a particular point of time. So I hope critical section is clear to you, and the critical section problem needs a solution to synchronize the different processes, and its solution include mutual exclusion, progress, no starvation or bounded waiting. So let's start with the mutual exclusion first. Okay, so what is mutual exclusion? If a process is running in the critical section, let's say process P1 is running on its critical section, no other process should be allowed to run in that section at the particular time. Let's say process P1 is in its critical section for next 10 seconds. For these 10 seconds, no other process is allowed to enter the critical section area. Okay. Next is progress. So if no process is still in the critical section and other processes are waiting outside this particular section to execute, then any one of the thread must permitted to enter the critical section. Means what? If no process is there, if no process is inside the critical section and other process, मान लीजिए process P2 is waiting to go inside this section to execute its request, okay, then any of the thread must be permitted to enter the critical section. So any of the thread is allowed to enter that particular section, and the decision of which process will enter the critical section will be taken by only those processes that are not executing in the remaining sections. So this is the progress of a process synchronization. Next is no starvation. So starvation means what? Starvation means a process keeps waiting, a process keeps waiting forever to access the critical section. To access the critical section, this is known as starvation. So no starvation is also known as bounded waiting. Bounded waiting. I have told you these three types: mutual exclusion, progress and no starvation. It is also known as bounded waiting, right? Here, a process should not wait forever to enter inside the critical section. And when a process submits a request to access the critical section, then there should be a limit or bound, which is the number of other processes that are allowed to access the critical section before it. Okay, and after this bound is reached, the process should be allowed to access the critical section. So this is the bounded waiting. Okay, so these are the requirements of using the synchronization in operating system. Now students, as we have discussed about the critical section, I hope everything is clear till now. Now we have critical section is what? It is a major problem in operating system. Okay, and very important topic for every examination. And to solve this critical section problem, we have some solutions. First is Peterson's solution. Okay, so Peterson's approach to critical section problems is extensively utilized, and it is a classical software based solution. It is a classical software based solution. This solution is based on the idea that you can say when a process is executing a critical section, when a process is executing a critical section, then the other process executes the rest of the code, and vice versa is also possible here. That is, this solution makes sure that only one process executes the critical section at a particular point of time. So in Peterson's solution, we have two shared variables. Okay, generally in process synchronization, we use only one shared space, but in Peterson's solution, we have two shared variables that are used by the processes, and these two shared variables are, first is Boolean flag. Boolean flag, okay, Boolean array flag, which is initiated to false. Initiated to false always, okay? Another is int turn. These two variables are very important. First is Boolean flag, which is initiated to false, and this flag array represents which process is which process wants to enter into the critical section. Okay, it defines which process wants to enter the critical section, and it is an array, so we can use these brackets. This is the symbol of an array. Okay, next is int turn. An integer variable turn indicates the process number. So turn indicates what? It indicates the process number which is ready to enter the critical section. Now, in Peterson's solution, we have some disadvantages of using it. First disadvantage is Peterson's solution involves busy waiting. Peterson's solution involves busy waiting, means at any point of time a process ऐसी कंडीशन में फंस जाता है जहां पर उनको लाइफ टाइम भी वेट करना पड़ सकता है. दैट इज कॉल्ड बिजी वेटिंग. The solution is also limited to only two processes. Okay, it is a solution. Peterson's solution is a solution to critical section, but it is a solution to only two processes. If we have 3, 4, 5 or more than 10 processes, Peterson's solution will not help you. Okay, so I hope students everything is clear till now. If you have any doubt, you can comment below. I will definitely help you. So thank you so much.